Hi everybody. Today we're going to do a brief study of the first derivative test. We're going to just look at one component of it, and then tomorrow we'll look at the second component. Today what we're going to do is we're going to look at how to determine something is a maximum or a minimum using the first derivative test. Okay, before we get into that though, let's just look at the few things that the first derivative test will actually tell us. Okay, the first thing it'll tell us is the location of what we call relative or local maximums and minimums. Okay. The second thing it will tell us, and this is important as well, and we're going to focus on this part today, and tomorrow we're going to focus on the second part, which is the intervals of x, where f of x is increasing or decreasing. Okay. Okay, so the intervals of x where the graph is increasing or decreasing. Those are the two primary things, excuse me, that the first derivative test will tell us. So we're going to look at two problems, and I'm going to show you how to set things up with the first derivative test to determine where it is where it has a maximum and where it may have a minimum, or both. Okay, so the first thing is find the critical values. So step one is find critical values. You might even want to pause and write that down, that step one is to find all critical values. Well, I'll even do it. Find all critical values. Okay, remember that yesterday, what we did with finding critical values over the past couple days is take the derivative and set it equal to 0. So dy dx is equal to 6 minus 2x. Set that equal to 0, and we get x equals 3. And that is the only critical value because there are no places this one is undefined. So we put that on a number line. Beep. And this is the next step, is to build a number line with your critical values. Okay, so we put the number on the number line, and this is the first derivative number line. Okay, and you can put an f prime or a y prime here. And what we're going to do now is test whether or not the derivative is positive or negative on this side of 3 and on that side of 3. So to do this, of course, since it's first derivative, we're going to test values in the derivative. So I'm going to pick a number less than 3, like 0. Okay, and if I plug 0 in, let's see here, 6 minus 2 times 0 is 6, which is positive. So that means I'm going to put a positive sign in this region. Okay, and then I pick a number from up in here, say 4. So I do 6 minus 2 times 4 equals, well, that's 6 minus 8. So that's negative 2, and our sign here is negative. So that means this region is a negative. Okay, well, what does that tell us? It tells us a lot. Basically, what it's telling me is on this side of 3, the graph is going up. And on this side of 3, the graph is going down. Okay, so what does that tell me about a maximum? That this is, well, it tells me, I'm sorry, that this is a maximum. Okay, so at x equals 3. Okay, you have a maximum at x equals 3, and the the true max is, all right, how you would calculate the maximum value is you take the 3 and you plug it into here, the original. So it would be, the coordinate of that maximum would be 3 comma 9 if we substitute it in, because that would be 18 minus 9, and that gives me 9, and this is our maximum value. Okay, now the key here is, and this is, you need to understand, I'm going to add a new page. A max occurs when f prime changes from positive to negative. Okay? Max occurs when f prime changes from positive to negative. And on the contrary, on the other hand, a minimum will occur when f prime changes from negative to positive. Okay, so you want to make sure you take this down and get these notes in. That a maximum occurs when the derivative changes from positive to negative, and a minimum occurs when we change from negative to positive. So be sure you get this note, pause, copy it down, do what it takes. Okay. Now, so let's look at one more example. Here we have one. We take the derivative. This would be 36x to the third minus 4x equals, and then of course find critical values. So that equals 0. Remember, the first step is to find the critical values, which means take the derivative, set it equal to 0, and solve for x. So now I'm going to factor out a 4x. That gives me 9x squared minus 1 equals 0. Therefore, x would equal 0, and x would equal plus or minus 1/3 if you solve this correctly. And you can do that. Remember, you just do 9x squared minus 1 equals 0. So 9x squared equals 1, or x squared equals 1/9, and then take the square root, and we get this. Okay? So now we set up the number line. Remember, just draw your number line, label it as the first derivative, and then put on your different values. Now you're going to have to maybe use a calculator here to help you out a little bit to determine the negative and positive regions of this graph if you don't know your fractions that well. Okay, so what I'm going to do is I'm going to first pick a number out here and determine whether it's positive or negative. Okay, so let's pick a number greater than 1/3, like 1, and plug it into our derivative. That would be 36 minus 4. Okay, 36 minus 4 is 32, or you could plug it in here and that would be 4 times 8, which is still a positive number. Okay, so we put a plus sign. Then I'm going to do the easy one out here too, which would be negative 1. Okay, and if we put, that would be negative 4 times 8, and that would be negative 32. So this region is negative. All right. Well, then we try a number in between, and the number I can think of is 1/4. Okay, 1/4. So if we do that, if we plug it in, we basically get a positive number times a negative number, which would be negative. Okay, so this region is negative. Use your calculator there, check it out. We're only interested in the sign, remember. Okay, then I'm going to try negative 1/4, which is in about here. That would be a negative number times a negative number tells me positive. Okay, we've just pretty much built our number line. We just now need to determine where the maxes and mins are. Now remember, I said in our notes on the previous page that a maximum occurs when it goes from positive to negative. So here we have a maximum. Okay, now I also said a minimum occurs when it goes from negative to positive. So here we have a minimum, and here we have a minimum. Okay, so we go minimum, positive, minimum, maximum, minimum. So we say at x equals negative 1/3 and positive 1/3, we have a min. Okay, and at x equals 0, we have a max. And what this tells me is this graph is doing something like this if we were to graph it. And you could take a look at it on your calculator. Now, sometimes I will actually ask what is the maximum value, and that means you have to take these and plug them back into the original. Whenever I'm asking for the maximum value, you do have to plug back into the original. All right? Well, that's it for today. Just keep these notes on hand. We'll use them in class and be ready to go.